Welcome to your Algebra 2 Lesson 8.5. Today you're going to add and subtract rational expressions, and you're going to find it's very much like adding and subtracting basic fractions. Alright, just like with regular fractions, life is good when you're adding and subtracting if you have like or common denominators. To add or subtract rational expressions with like denominators, simply add or subtract their numerators and use the common denominator. Then place the result over the common denominator. Let A, B, and C be polynomials with C not equal to 0. Why can't C equal 0? Well, because it's in the denominator and it would make the whole thing undefined. So for addition, if you have A over C plus B over C is equal to A plus B over C. A over C minus B over C is A minus B over C. Alright, so we're going to perform the indicated operation. We've got A and B there. For A, we're doing 7 over 4x plus 3 over 4x. We're going to add the numerators and simplify the result. So we're going to have 7 plus 3 over 4x, which is 10 over 4x. The 10 is equal to 2 times 5, and 4x is equal to 2 times 2x. So we can cancel 2's and end up with 5 over 2x. 2x over the sum x plus 6 minus 5 over the sum x plus 6. Okay, we've got a common denominator, so we're going to use our common denominator, and we're actually going to do the subtraction with the numerators. So 2x minus 5 over x plus 6. We look to see if we can factor. We have to think about it a little more on this one, because if you look, we've got a binomial over a binomial. Up here, we just had monomials. Super duper easy. I know y'all can reduce those, no problem. Here you have to think, okay, can I factor something out? And if so, then can I cancel? We can't factor anything out of the top. We can't factor anything out of the bottom. They don't match up exactly, so there is no simplifying there. Now, things become more interesting when you don't have the same denominator, just like it does when you're just adding and subtracting just numerical fractions. Alright, so when you have unlike denominators, what do? To add or subtract two rational expressions with unlike denominators, find the least common denominator, the LCD, which is the least common multiple of the denominators. Write each rational expression using the LCD, then add or subtract using the procedure for like denominators, because at that point you'll have like denominators. Let A, B, C, and D be polynomials with C not equal to 0 and D not equal to 0. Again, C can't equal 0 because it's a denominator. Well, so is D. So neither one of them can be 0, or we're going to have something that's undefined. Okay, so if I was going to add A over C plus B over D, the least common denominator would be C times D. So I would need to multiply on top and bottom of that first fraction by a D, and I would need to multiply on top and bottom of the second fraction by C, and so I would end up with AD over CD plus BC over CD, and so I would use my common denominator of CD, and I would add AD plus BC. Subtraction works the same way. Okay, you end up with AD minus BC over CD. Alright, just to practice finding least common denominators, let's find the least common multiple of 4x squared and 6x squared minus 24x plus 24. A least common denominator is a least common multiple that comes from looking at two denominators. Alright, so what you do is you consider the factor of each polynomial. Write numerical factors as products of primes. That way you can make sure you end up with the least common multiple. Alright, so looking at 4x squared minus 16, remember the first thing you always do is look for a greatest common factor. We can pull a 4 out of both those terms, and so we have 4 times x squared minus 4. We got a difference of 2 squares there, that's dots, so that's going to be x plus 2x minus 2. 4, we want to go ahead and write as 2 squared. Alright, then we've got 6x squared minus 24x plus 24, so we can pull out a 6 out of all three terms. So we have 6 times x squared minus 4x plus 4. And let's see, x squared minus 4x plus 4, that's a perfect square trinomial. Psst, remember that PST? That's the big secret, always look for that. The square root of 4 is 2, and so this is x minus 2 squared. And then 6 written as a product of primes is 2 times 3. All right, our next step, you're going to form the least common multiple by writing each factor to the highest power it occurs in either polynomial. So, for instance, we've got a 2 and a 2 squared. Well, 2 squared is to a higher power than 2 to the first. So we're going to have a 2 squared in our least common multiple. We're going to have a 3. We're going to have a plain x plus 2. And let's see, we've got an x minus 2 and an x minus 2 squared. We go with the larger power, so we'll have an x minus 2 squared. So, just like I said, we're going to have a 2 squared, because the highest power of 2 is 2 squared. We're going to have a 3. We're going to have an x plus 2. And then we're going to have an x minus 2 squared. So, we're going to have 4 times 3, which is 12, times x plus 2 times x minus 2 squared. Okay, so now let's use that skill to add two rational expressions with unlike denominators. So we've got 7 over 9x squared plus x over the sum 3x squared plus 3x. All right, for 9x squared, it can be helpful to think of that as 3 squared times x squared. And then we've got 3x squared plus 3x. We can pull a 3x out of both those terms. And that's going to leave us with x plus 1 because 3x squared divided by 3x is x. And then plus, and 3x divided by 3x is 1. Remember, you have to do the plus 1 to hold that spot. Okay, so the least common denominator is going to be, let's see, we have 3 squared and 3, so it's going to be 3 squared. We've got x and x squared, so x squared. And let's see, we've got x plus 1, so x plus 1. So 9x squared times x plus 1. Now, let's recopy, but let's rewrite the 3x squared plus 3x in factored form. So we're going to have 7 over 9x squared plus x over 3x times x plus 1. Now, what we're going to do is we're going to get common denominators by multiplying by whatever each of the two denominators needs. But whatever we multiply by on the bottom, we have to multiply by on the top so that we're changing the form but not the value. You want to multiply by a fancy form of 1. Okay, so if our least common denominator is 9x squared times x plus 1, what's missing from the top and bottom is x plus 1. So you need to multiply on the bottom by x plus 1 and on top by x plus 1. I really like to put parentheses around those when we're doing this. You can if that's helpful to you. I think it is. So I would put parentheses around those x plus 1s. All right, and then we've got x over 3x times x plus 1. And so we're going to multiply on top and bottom. Let's see, if I've got a 3 and I need a 9, I'm going to multiply by 3. And if I've got x and I need x squared, I'm going to multiply by an x. So I'm going to multiply on top and bottom by 3x. All right, your next step is to actually multiply the top together, multiply the bottom together for the first fraction, multiply the tops together, multiply the bottoms together for the second fraction. So when we do 7 times x plus 1, we're going to distribute the 7 to be 7x plus 7. And you want to actually carry out the multiplication in the numerator. In the denominator, we just want to show that we've multiplied them together. We don't actually want to carry it out. So we'll have 9x squared times x plus 1, and then plus 3x squared, because we had x times 3x, over 9x squared times x plus 1. Okay, so we went ahead and did the 3x times the 3x. We just got it in the form of the least common denominator. All right, now that we have our least common denominator, we add our numerators together and use our least common denominator. So let's see, we're going to put it in standard form. So we're doing 7x plus 7 plus 3x squared, but standard form tells us to write the 3x squared first, plus 7x plus 7, and it's all over 9x squared times x plus 1. Now, at this point, you look to see if you can factor, and if you can factor the numerator, you factor, and then you look to see if you can cancel. This is a prime numerator. If we cannot factor the numerator, which that's what prime means, then we cannot cancel. You must be able to factor after you've actually added the two fractions together, or in case of subtraction, you've done your subtraction. At this point, if there's going to be any canceling, you have to be able to factor. We can't factor this, so we cannot cancel. We are done. All right, so now we're going to subtract. Okay, we've got x plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. Okay, we need a common denominator, so we're going to have to write the denominators in factored form. Now, you can either do this as a whole separate step. I like the way they're doing it in this problem better, actually, than the previous example, where you just go ahead and factor in the denominator. Okay, I can factor out a 2 out of 2x squared, 2x minus 2, and that leaves me with 2 times x minus 1. And then let's see, x squared minus 4x plus 3, that's a trinomial, so we need the two little parentheses, and we're going to need an x and an x. We need numbers that multiply to be 3 and add to be negative 4, so minus 1 and minus 3 work. They multiply to be positive 3. We do our outside terms, our inside terms, they combine to be negative 4x. So now we're ready to determine our least common denominator. So our least common denominator is going to be 2, and then x minus 1. They both have the x minus 1, and then x minus 3. Okay. All right, so the first fraction needs to be multiplied on top and bottom by x minus 3, because that's what's missing from the denominator. The second term needs to be multiplied on top and bottom by 2, because that's what's missing from that denominator. Okay. So we're going to have x plus 2 over 2 times x minus 1 times x minus 3 over x minus 3. Whatever you do to the bottom, you have to do to the top. And then over here, we're going to take that second fraction and multiply by 2 over 2. All right, so we're actually going to do our multiplication. Now here, x plus 2 times x minus 3. We've got a binomial times a binomial, so what do we need to do? That's right, we need a FOIL. Because remember, for numerators, you actually carry out the multiplication. For denominators, you just show that the factors are multiplied together. So let's see. We've got x squared minus 3x plus 2x. So those combine to give you minus x. 2 times negative 3 is negative 6. So we've got x squared minus x minus 6. And then all over 2 times x minus 1 times x minus 3. And then minus the whole entire fraction here of negative. Let's see, we're going to multiply negative 2x minus 1 times 2, so we get negative 4x minus 2, because we distribute that 2. And this is all over 2 times x minus 1 times x minus 3. So, now we're ready to subtract the numerators. We use our common denominator. So we're going to have x squared minus x minus 6 minus the whole entire second denominator. So, minus and then negative 4x minus 2. All over our common denominator. Let's simplify the numerator. So let's see, we've got x squared. So x squared comes down there. Minus x and then minus negative 4x. So that's negative x plus, because minus a negative is the same thing as adding a positive. So negative x plus 4x gives us plus 3x. Negative 6 minus negative 2. So minus a negative means we're actually going to add. So negative 6 plus 2 gives us negative 4. All right. Now, the next question is, well, can we simplify? So let's see. Let's factor the numerator, and this time we can, and divide out if there's a common factor. So the numerators are trinomial. So we're going to have x plus or minus something times x plus or minus something if we can factor it. So let's see. Things that multiply to be negative 4 and add to be positive 3. Minus 1 and positive 4. Those multiply to be negative 4. Negative 1x plus 4x gives us 3x. So that is a correct factorization of x squared plus 3x minus 4. So now we start looking, and remember, it's all or nothing. The binomials match up completely, or we can't cancel them. Well, we have an x minus 1 on top and an x minus 1 on bottom, so those two cancel, and so we're left with x plus 4 over 2 times x minus 3. Okay, last concept and last example, complex fraction. A complex fraction is a fraction that contains a fraction in its numerator or denominator. So it's a fraction that has a fraction in it. The easiest way to simplify a complex fraction is to multiply the numerator and the denominator by the least common denominator of every fraction in the numerator and the denominator. And then you simplify. So let's look at that. So we've got 5 over x plus 4 divided by the sum of 1 over x plus 4 plus 2 over x. Alright, so remember what we're going to do is we're going to multiply the top and the bottom by the least common denominator for every fraction in the problem. So our least common denominator, let's see, it's going to have an x plus 4 from this fraction. This one has a denominator of x plus 4, so we've already got that taken care of, and this one has x. So x times x plus 4 has to be our least common denominator. Alright, so we're going to take that original fraction, and we're going to multiply the numerator and denominator by x times x plus 4. Alright, so 5 over x plus 4 is going to get multiplied by x times x plus 4. 1 over x plus 4 plus 2 over x is going to get multiplied by x times x plus 4. Alright, so let's just look at the numerator right now. This 5 over x plus 4 times x plus 4. This x plus 4 is going to cancel with that x plus 4, and we're going to get 5x. Okay. Now, on the bottom, we're going to need to distribute the x times x plus 4 to the 1 over x plus 4, and then we're going to need to distribute it to the 2x. So let's just consider x times x plus 4 times 1 over x plus 4. This x plus 4 will cancel with this x plus 4, and we'll be left with 1 times x. So that's where this x comes from. Now, when we distribute the x over x plus 4 to 2 over x, the x will cancel with the x, and we'll have 2 times x plus 4. Okay? So, we end up with 5 over x plus 2 times x plus 4. Well, we need to simplify that. We can leave the bottom factored out, but this isn't factored out because you've got this plus out here that's outside parentheses. So we need to simplify, then see maybe if we can factor. All right. So we distribute the 2 to give us 2x plus 8. And then we add another x. So x plus 2x is 3x, and then plus 8. We look to see if we can factor anything out. We can't, so we know we're done. Okay, we don't cancel unless we can factor. It's factor then cancel. We can't factor, so we are done. Okay, guys, I know complex fractions in particular are a little difficult, so if you cannot do the problems to try on your own, come in. Let's talk about what you've got and how you work with these different kinds of problems, and let me help you out enough where you can get those problems to try on your own done before class starts so that you can use all of your class time to work on rounds. Okay, guys, that's it for this lesson. You'll have a great day, and I will see you soon.